Hello and welcome everyone. Thank you for joining us today for our webinar titled Automatic Model Documentation with H2O. My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Lauren DiPerna is our data scientist here at H2O.ai. Before I hand it over to Lauren, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab. We will be happy to answer them towards the end of the webinar. This webinar is being recorded. A copy of the webinar recording and slide deck will be available after the presentation is over. Without further ado, I'd like to hand it over to Lauren.
Thanks so much for the introduction, Shavar. And welcome everybody to the H2O AutoDoc webinar. H2O AutoDoc is one of H2O's latest products for automatic documentation. For this webinar, the outline is going to be, we'll start with what exactly H2O AutoDoc is. Then we'll talk about some of the features and capabilities of the AutoDoc before doing a deep dive into an example AutoDoc report so you can see exactly what is in the report and sort of make a mental note of the things that the report is automating for you or would automate in your workflow. Once you understand the motivation behind AutoDoc and have seen the report, hopefully you'll be inspired to actually generate your own report. So at that point, I'll show you what the API code looks like. For anybody who's familiar with Python, the learning curve is basically 0. It's just an additional 4 lines of code that you'll add to your script, and that's all that it takes to generate the AutoDoc. So to start off, I just wanted to give a motivation for why you might want to use AutoDoc. And again, just a quick high level so everybody's on the same page. The AutoDoc is a generated document that can be generated on any H2O3 supervised learning model. So with that in mind, let's talk a little bit about the data science workflow. So generally, a data scientist or a model developer will be working on a model for about a few weeks or a few months or longer. And then once the model is finally ready, they'll want to put it into production. But generally, there's the barrier of having to document your model. And this can be problematic because maybe you need to get your model into production sooner than later. But as a model developer at that stage, you'll probably have to go back in time and get additional artifacts, including model performance metrics. So this may mean rerunning your model on the data sets to get the performance metrics. It might mean including additional plots, including calibration plots that you can showcase in your model document report. And then you probably have to provide summary statistics for the data set that you used for training your model, along with some plots, maybe some shift detection plots, all of which can take time to regenerate and are a little bit of a hassle if you didn't keep track of these things along the way. And then finally, once you've created all of these artifacts, then you can finally start creating this document, which could take you weeks to generate, depending on the level of detail that you need and the industry that you're in. So the motivation behind why you'd want to use AutoDoc is because you can just start off with that model finished, run the 4 lines of code that you need, and automatically start with a really good baseline model, which is the H2O's default AutoDoc. So in summary, the takeaway points are, the AutoDoc should save you quite a bit of time, whether you're the model developer or you're managing a data science team. The reporting that you are going to get is going to be consistent and comprehensive. And so what I mean by that is that each report is going to be using the same type of calculations. You don't have to worry that maybe a metric was calculated differently between your data scientists. And then you also are going to get, in general, about 20 pages of automatic technical content with the out-of-the-box AutoDoc. And finally, I'll keep emphasizing this throughout the webinar, but the AutoDoc is incredibly simple to use. It's really just 4 lines of code, which I will show you at the end of the presentation. The next segment of this presentation is going to cover in more detail what the AutoDoc supports. And the concept of support in the AutoDoc world is really the templates that you're allowed to pass the AutoDoc. So the AutoDoc can either provide you with the out-of-the-box template or you can provide your own custom templates. And then the second part of support is what models are supported. So as I mentioned earlier, the AutoDoc is for H2O3 models and specifically for the supervised learning models. So I'm going to touch in more detail on both of these topics, starting with the templates. So the templates that you can generate with the AutoDoc are either Word documents or Markdown files. In the past, we found that PDF files are not preferred to these because they're not editable. So the document that you get, you're going to want to edit it and add use case specific details. Out of the box, you will get the AutoDoc default template, and this is the one that I will show you in extensive detail after this first set of slides. Additionally, you can provide your own custom templates. I just here have an example of a model card that has been completed. If you're working in a regulated industry, what we found is that customers will provide us with their regulatory template, and then we'll work closely with them to decide which sections they want us to auto-populate. If there's a feature that doesn't exist in the AutoDoc yet, that's feedback you can give us, and we can work to add that feature. The length of the template is obviously up to you. You can have a 100-page template or a 1-page template. That's the nice thing about the customization. So hopefully you have a good sense of the type of templates that you can input and the file format that's output at this point. Next, we'll talk about the supervised models that are supported. So in H2O3, the platform supports supervised learning and unsupervised learning. But for AutoDoc right now, we're focused on the supervised learning models. The models that we can generate documentation for are our generalized linear models, our GBM models, so this is both the gradient boosted machine that's available in H2O3 and XGBoost. We can also provide model documentation for random forest. And in H2O3, the random forest options are our distributed random forest and extremely randomized trees. And then finally, there's also support for H2O3's multi-layer perceptron. So that should give you a good sense of whether or not this is a document that you could use right now, given the models that you're training. So now that you have the motivation for the AutoDoc and an understanding of what's supported, I just want to highlight a few of the features that we have in our document before going through a rendered example. The first section of the AutoDoc is going to cover a data overview. So this is just a high level of some of the most interesting features. In the data overview section, you'll see shift detection. So that'll show you if there's any problematic features. Maybe you trained your model on a population that doesn't match the population you're planning to test on. We also provide you with summary statistics for categorical and numeric features. These are going to be standard summary statistics that you could easily get, but it's a nice add because you don't have to go back in time and recreate these plots or charts. The next section of the AutoDoc will have model overview. There's quite an assortment of details in this section, but the two things I want to highlight are the calibration plot that's available and the performance metrics. So the performance metrics that we will provide are based off of the performance metrics that are available in H2O3. The last set of features that I want to highlight are the model interpretability features. So with every AutoDoc, you will see a model's feature importance. We'll provide you with the model's built-in feature importance. And if the model supports it, we'll provide you with the Shapley values. We will also provide you with partial dependence plots so you can get a sense of how changing a feature's value affects the average target value. So those are some of the most interesting features that we have. Please keep those in mind because we will be covering them in detail in the actual walkthrough. So the walkthrough is going to go over the out-of-the-box template that you get with AutoDoc, and then we'll cover the 4 lines of code that I have on the right-hand side that you will be using to generate the AutoDoc. Now I'm going to switch to the document. So the first thing I want to point out, this is the document that after you run the code you will get. And there are a couple things I want to point out before we start the actual walkthrough. The first thing is to notice the table of contents. So this is actually showing you pretty much the entire data science workflow, starting with your experiment overview, data summary statistics, all the way to your final model overview, and even the ability to pass in alternative models. Please note that the alternative models do have to be H2O3 models as well. And then there's the partial dependence plots that I mentioned just before, which is your model interpretability section. The other thing I want to point out about this document is the number of pages that were generated. So you can see here we have about 24 pages. So again, this is all automatic content where I haven't typed any additional information. So with that, I'll start the walkthrough. And I think the main thing to think about while we're doing this walkthrough is just how much of this is automating work that you currently have to do or work that your data scientists have to do. One thing you will notice in the experiment overview is that a model developer, once they get this section, they will need to add information about the use case and what the model's intended uses are. So that's not content that we can generate for you, but the AutoDoc isn't meant to replace the data scientist. It's really meant to enhance their workflow. So the first thing you'll notice is which model was built. So this will tell you that this was a GBM model and what it was trying to predict. For a bit of context, this document was generated on a use case where we had credit card data and we wanted to predict whether or not a customer was going to default on their next month's payment. The default payment next month is actually the name of the feature in the data set, so whatever you identify as your target will populate here. We also provide you with the number of features in the data set, so there were 23 features, and we let you know whether this was marked as a classification or regression problem. In this case, this is a binary classification problem. Did you default, or will you default, or will you not default? You can also see that this particular model completed in less than a second. So it was a very simple model on a smaller data set. The next piece of information is the performance high-level overview. So you can see that I provided a validation data set. You can see what AUC it got. And then you can see that no test data set was provided. So a quick note on the test data set. In the AutoDoc, you have the ability to add additional data sets. So this is a test data set that was not used during the model training phase. So this can be really nice if you have some additional holdout data set that you want to get performance metrics on. The next table is going to be the system specifications. If you are a H2O3 user, you should be very familiar with this output. It's the output from the H2O cluster when you use H2O.init. The main things I'll point out in this table is the H2O3 cluster version. And the reason I point it out is because we also provide you with the Python client version, and you just want to make sure that these two versions match. So that's just a quick sanity check that you can do. The next section is the data overview section. So we did touch on this earlier. This is a nice section. It provides you with the summary statistics. And what it'll do is it'll look at your training data set and provide you statistics based off of feature type. So we'll start off with the numeric columns, and then we'll provide you with information about the categorical columns. And what you can see here is these are the features that were used in the credit card data set. We have things like the limit balance, how old the customer was, and then we can see whether or not the customer paid off their first month's payment, second month's payment, and so on time or late, so up to 8 months late. You can also see the bill amount for each of those months, as well as the actual payment amount. For the categorical columns, we tell you how many unique categorical levels there are, what the top most frequent categorical is, and the frequency of that categorical value. So those are standard summary statistics, but it's nice just because you get it automatically out of the box. The next interesting feature is the shift detection feature. So this feature is nice because you can quickly see if there are any kind of problematic feature distributions. Now what you're seeing here is that we do have an age column, as I mentioned, and the problem is that the training data was only trained on people under 50, and the validation data was trained on people over 50. So this is a very clear split, and part of the reason it's so clear is because it's an artificial shift that I created so that I could demonstrate this feature in the AutoDoc. The next section is the validation strategy section, and this is also a section that's specific to H2O3 models. So in H2O3, you have the ability to provide data splits. In this case, I did provide a train and valid data split, so you'll only see the shape of the validation data set. But you can also specify a fold column or the number of folds using random k-fold cross-validation. In either of those cases, we will provide that information. So if you provide a fold column, we'll provide the name of the fold column and the number of folds. The next bit of the validation strategy that we wanted to include is whether or not early stopping was enabled. If it was turned on, in the case of this model, we'll provide you with the parameters that were used for early stopping, and then we'll also provide you with an overview of what exactly they are and how they work. And part of the reason we do that is so that even somebody who may not be familiar with H2O3's early stopping mechanism can read about the details. The next section is feature importance. So this is a pretty nice section. We provide you with what we call native importance, and that's going to be the model-specific importance, which will depend on whether you're using a GBM or a GLM, so that can change. We also provide you with Shapley values. And the Shapley values are only provided for H2O3 models that support SHAP values. This was built on a GBM, and H2O3 does support SHAP on GBMs, so you'll see the Shapley values in this table. The information is provided in table form and plot form. And we do that because people have generally liked to have the ability of seeing the granularity of the feature values and then also seeing it quickly and digestibly in a plot form. One quick thing to note about this plot is there are about 20 features that we include by default, and then the rest are clumped into others. One reason we do that is so that you can quickly see whether maybe your most important feature is more important than all the other features grouped together, or maybe you see that if you group all the other features together, it actually has a greater feature importance than one of your top features. So that's a nice add. The next section is about the final model. The final model section will provide you with the model summary table. So this is going to give you a table with the hyperparameters, some hyperparameters of the model, a few internal parameters, and other configuration parameters. For GBM, the ones that are most interesting are the number of trees and max depth in this case. We also provide you with performance metrics. So this is a classification problem, as I've mentioned. So you're going to see all the available classification metrics in H2O3. If this had been a regression problem, you would see the regression metrics in this table. And then we provide it for the dataset splits. Again, this was a model that was trained using a training dataset and a validation dataset. Since this is a binary classification problem, we'll provide you with a confusion matrix in plot form and table form. Again, so you have that granularity and a little bit of extra information if you're curious about the error rate. In terms of auto-population, I just want to note that this number here is auto-populated. It's the threshold used for the confusion matrix, and it'll always be the max F1 score for H2O3 models. The next set of plots are standard classification plots that most people would like to see, including the ROC curve, the cumulative lift, and the cumulative gain. Another nice thing about H2O is it provides you with the scoring history. So you can kind of quickly see if there's a point maybe where your model is actually starting to overfit. So we see that sort of happening around the 10th tree. So that concludes the overview of your data and the overview of your final model performance metrics. The next section is really focused on your predictions. So we want to provide you with prediction statistics in great detail. And depending on the industry that you're in, some of these metrics will be more familiar to you than others. The first metric that we cover is the population stability index. So this really tells you whether or not there's a shift between your prediction scores from your training data set and your validation data set. We would also provide this for a test data set if you had provided one. In this section, we provide you with a little bit of content, including what the standard rule of thumb for PSI is. So basically, if you have values between 0.1 and 0.25, you're probably okay, but if you have a value greater than 0.25, it might merit a little bit more investigation. In this particular use case, the validation data set is not showing a great shift, so that would hopefully imply that our model will generalize well. One thing I want to quickly note here is there's a little note that tells you that the PSI calculations can be found in the appendix. So we do provide a calculation table with all the details required to get this number. Continuing with more prediction statistics, we provide you with a table where we bin the training data into quantiles and then provide you summary statistics, mean, median, mean, and max. And the nice thing about this table is you have it in table format, but then you also have it in plot format. And this makes it a little bit easier to digest. And then there's also the ability to quickly visually verify if your predictions in your training data set match the shape of your predictions in your validation data set. Continuing with prediction performance metrics, we can look at the quantile response rate. So in this plot, visually, you want to just inspect it and make sure that the trend is generally going down. Hopefully you have a monotonic decrease. If there's a little bit of a wiggle, that's probably okay, but if you're seeing big jumps, that's another moment where you're going to want to do further investigation. The next two set of plots are our calibration plots, which we provide to you in the probability and log odds space. And we provide you with a little bit of context if you want to read more about it. In this case, we can see this is a calibration plot for a GBM, and it sort of overestimates and then underestimates towards the top. Depending on your use case, the calibration may be very important or it may not be. This sort of S shape is pretty common with the GBM. And as I mentioned, we also provide this in the log odds space if you'd like to look at the values over a different range. The quantile-based plots have a calculation table that can also be found in the appendix, and so I'll touch on that quickly at the very end. As I mentioned, you have the ability to provide alternative models. In this case, what I did is I built an AutoDoc on a GBM where I added a few tuned parameters, but I wanted to see how it would compare to H2O3's out-of-the-box GBM. So this is a default GBM, and I can see what the training metrics are for this GBM. If I wanted to pass in additional models, that could be an additional GBM. It would populate here. If I passed in GLM, for example, you'd see that table further down. So that's a nice way to add in additional models that maybe you trained during your modeling process and you want to showcase in the report. And then the final section is your model interpretability section. So this is the partial dependence plots. And what these plots do is they tell you if you were to change a value in your feature, how much does that affect the target on average? For this report, I actually picked out the features I wanted to see that I found the most interesting. But by default, if you don't specify features, you will see the top 20 most important features in your PDP plot section. The first feature that I chose was pay zero. And as you can see, what this shows is that people that pay their first month off, if it's a negative value, it means they either had a credit balance or they had no balance at all. You can see that they have a lower probability of default on average than the people that paid their first month payment off late. And so this kind of intuitively makes sense. If you are already starting off late for your first payment, that could be problematic. The other thing I want to note are the diamonds in this plot. So these are out of range value PDPs. And these are basically values that do not appear in the data set. And we provide 3 standard deviations, but this is configurable. We also provide you with a histogram directly below so you can quickly get a sense of which values are most present in the data set. The next PDP that I wanted to look at was the limit balance. So this one is less drastic, but we can generally see that on average, the higher your limit balance, the less likely you are to pay off your credit card, the less likely you are to default. But it's not a very drastic change. And then you can also see the histogram there below as well. And the last one that I wanted to look at was age. And this one really doesn't seem to make much of a difference. As I mentioned, the training data was only on people less than 50, so that's a thing you can quickly check by looking at the histogram. So there doesn't seem to be much of a difference in age, so maybe this isn't a feature that I want to keep in my modeling process. So that's the deep dive overview of the AutoDoc. I'll just quickly note in the appendix, as promised, there is a calculation table for the population stability index. We provide you with definitions for each of the columns in the data set. This is a way where you can look over the calculation table. And then we also do the same thing for the quantile plot. So that wraps up the document. Hopefully, as we went through this document, you were able to identify sections that you've been doing manually that would be nice to automate. And that's motivating you to find out more about the AutoDoc and want to learn how to code this up. So on that note, let me just jump over to the coding walkthrough. So one thing that I haven't addressed is the workflow for the AutoDoc. Currently, the AutoDoc requires Steam. Steam is another H2O3. Steam is another H2O product. It's a way to securely launch or connect to an H2O cluster. And it's available to all enterprise customers. So if you are an enterprise customer, you should have access to Steam, and then you can get access to the AutoDoc. The workflow for this notebook assumes that you've started an H2O cluster from Steam. And the idea is that you would sign into Steam, connect to your H2O cluster. You would build your model, or you could load in a model you've already saved. And then you could go ahead and download the AutoDoc. So I'll walk through this workflow, but I'll really highlight the section where you have like the 3 to 4 lines of code to generate the AutoDoc. So starting with the top, if you're familiar with Python, you're going to have your package imports. The only thing I really want to highlight is this one import line here. So the AutoDoc comes through the Steam Python API, so you're going to need to import the AutoDoc Configuration class, and you'll see me using this a bit later on, so just keep that in mind. The next step is connecting to an existing H2O cluster. So I would just pass in my connection. I would just pass in my credentials, and then I would go ahead and log in. And then I can connect to my running cluster. So the only other parameter that I want you to keep in mind, or Python object, is the cluster object, because this is what we're going to use a method on later on. The next part of the walkthrough is just the data preparation. So this can be pretty much anything that you do normally with your H2O modeling process. This is where I imported my credit card data set. This is where I created the artificial shift. So you can see the training data set did in fact have only people under 50, and the validation data set only had people over 50. Then I do the standard specify my predictors and response, maybe change some features to categoricals as needed. And then I can go ahead and build my H2O model. So this was me building a simple GBM where I specified early stopping parameters, and I specified the number of trees and max steps. So that was the very tiny amount of tuning that I did. Once you have the model, and again, you could do the model building phase in your cluster, or you could load a saved model. Then you can go ahead and create an AutoDoc. And it really is just about 3 lines of code. So the first thing is configuring the AutoDoc. There are, in fact, quite a few parameters that you can configure, but I would recommend the first time that you run the AutoDoc that you just use the default settings. The only thing you really have to specify, aside from your model, is your output file path. In this case, I'm just going to call it AutoDoc default webinar. I'm going to save it as a Word document, and I just want this to be saved in the same directory as my Jupyter notebook. Then to download the AutoDoc, you just run download_AutoDoc, and it's applied to that cluster object I had mentioned earlier on. And then you pass in your 3 required parameters. The model, so that was this GBM we created up here. The configuration, which we instantiated over here. And then the output file path. In Steam, what you'll see with the current release is you'll see just the text output that says generating AutoDoc. And then when it's completed, you'll see that it's been saved and where it's been saved to. In a future release, you'll also get a progress bar, and you'll be able to see the AutoDoc logs in the Steam UI. So the takeaway really is that the AutoDoc is very easy to create, and it only requires 3 lines of code to start off. Once you're comfortable with the most basic form of the out-of-box AutoDoc, then you can consider some more advanced AutoDoc features. So I'll just touch on these briefly. The first one is including an alternative model. So in the AutoDoc, if you remember back, I had in my alternative model section another GBM, which I mentioned was just the out-of-the-box GBM using default values. And as you can see, that's exactly what I did. I just use the default values. I'm specifying a seed in the model name, but that doesn't really affect the model. And then I went ahead and trained it. The alternative models is a parameter that's passed. You're going to pass in a list of H2O model objects. So here I just passed in a single GBM, but I could have passed in a random forest, a GLM, as many models as I want, basically. The other advanced feature that I had mentioned, which was not included in the AutoDoc, was the ability to provide a test data set that was not used during the model training process. And the way that you would do that is you would just import the test data set as an H2O frame, and then you would pass it as a parameter to the download AutoDoc function. The next set of advanced features are configuring the interpretability features. So that's having a bit more control over the partial dependence plots that are shown. If you remember back, I showed you 3 partial dependence plots, one for pay 0, one for limit balance, and one for age. This is how I customized it. Again, if I had left this blank and I didn't provide it, then out of the box, the AutoDoc is going to provide you the top 20 features at most. There's also the availability of ICE plots. So if you're familiar with individual conditional expectation plots, we do have a way to show those overlaid on the PDP plot. If you're not familiar about it, you can read more about them in our user guide. And then there's also the availability to disable or enable Shapley values. And so the point of this section isn't so that you memorize all the advanced features, but just so that you know that they're available and you know that you can pass them in as configurations. I just also want to show you like a visual of what it looks like to pass in additional configurations to the download AutoDoc parameter. So in this case, we're actually explicitly passing in all of our data frames, and then we're passing in the alternative models. The last thing I want to point out is the way to download the AutoDoc logs. And again, I will point you to the documentation. So this is all available in the user guide. So to download an AutoDoc, it's pretty straightforward. You just do download AutoDoc logs and then the log file name or the path to that file. So that's the overview of how you code up the AutoDoc. Again, the real takeaway is these 3 lines of code. So just configuration, output file, and download AutoDoc, and then you should be good to go. So just for visual of the workflow that we just went through, the idea is that you pass in a model and the data set that you use to train that model. Again, this can be a saved model or a model that you built in the live cluster. You would have enterprise theme where you'd have launched an H2O cluster. You'd run the AutoDoc code, and then it would output a template. I really focused on the out-of-the-box template, but if you have a custom template, there's a template parameter where you can specify where that template is located, and it will generate the AutoDoc for that template. And the last thing that I wanted to finish off with is the documentation. So if you're interested in reading more about the AutoDoc, you can go to the H2O.ai documentation webpage. It'll be under Enterprise Theme because that's how you get access to the AutoDoc. And the 2 documentation sources that I want to point out are the Python client documentation. So the webpage looks like this, and this is the hyperlink. The Python client documentation will show you the exact API documentation to generate the AutoDoc. And then there's also the ML AutoDoc documentation. So this reads like a user guide. It will cover everything we covered in this webinar, what file types are supported, what models are supported, what requirements there are. And it will also include several different examples, how to download the AutoDoc, and all of the different configurations that we covered in the webinar, plus more, are provided in code examples. So with that, I'll leave us on the Learning Center slide, and I'll take any questions that we have about the AutoDoc.
Thank you, Lauren. We have some great questions coming in the chat window. We'll try to get to all of them with time permitting. One question is this available for free, or is it a part of driverless AI product?
Yeah, so one thing I want to distinguish is that the AutoDoc, this particular one that we covered in the webinar, is actually for H2O3, which is an open source machine learning platform. It is completely separate from driverless. Driverless does have its own auto report. So when you run driverless, you do get a very similar looking document, but this particular product is for the H2O3 open source machine learning algorithms. The AutoDoc itself is not open source. It's only available, at least at this moment, through our Steam product, which is the product that allows you to securely launch and connect to H2O clusters.
Okay, perfect. I heard you mention a fold column. What does the fold column do?
Yeah, so the nice thing about the H2O3 open source platform is that you can specify how you want to do your validation for different models. So some people like to have just a simple train valid split and then another test holdout data set, and other people like to do what's called random k-fold cross-validation, or they can specify how they want those folds to be made. So when you use a fold column, you would actually directly specify how you want H2O to validate your model.
Perfect. Is there any out-of-the-box champion challenger comparison charts for various model builds, or is the documentation only available on a per model basis?
Yeah, so that's actually great feedback. Right now, what we have is what I showed, where you just have the ability to provide alternative models. But in the future, that would probably be a nice thing for us to add, where you can have that sort of plot-based comparison for champion challenger models. So we don't currently have that, but that's something that we would keep in mind for our roadmap. So thank you for bringing that up.
One question is it available in other languages other than English?
Yeah, I was thinking about that one recently. Right now, so right now the out-of-the-box one is only available in English. What I will say is that if you want to translate that one, we can work with you to create a translation and populate that. Or if you have a template that's in another language, we could very easily work with you to have that be your custom template that we auto-populate for you. Was there any follow-up on what languages people were interested in seeing?
Okay. Do you provide any charts for stress testing to measure performance when a particular input attribute is omitted?
We don't currently have that. We just have the out-of-range P2Ps.
Oh, gotcha. Okay. Can we use this for R?
We don't currently have a R API, but I'm sure if we have enough customers that would like an R API, that's something we can add.
Okay, perfect. What versions of H2O is the AutoDoc compatible with?
Yeah, so since we recently added the AutoDoc, the lowest version of H2O3 that we're compatible with is 324. And then it should work with any newer versions.
Wonderful. Do you provide access to the AutoDoc Artifacts?
Yeah, so this is a request that we've been noticing from customers where people, maybe they don't want to just have a Word document, they just want to have the artifacts that are in the document, so the images, the plots, or the tables. So right now, as I mentioned, you can get the AutoDoc as a Word file or a Markdown. If you save it as a Markdown, that will automatically come with a zip of all of the images, so all of the plots in the AutoDoc. So that would be one way to access those artifacts. For the tables, that's something that we're planning to add in the future.
Wonderful. Do we have a section that explains the algorithm on general hypothesis and how it derives? More of a general documentation.
Yeah, so one thing I will say, basically what you saw in the AutoDoc is what's covered, but when we have custom templates or regulatory templates, then those templates will have detailed descriptions of how each model works. So let's just take a GBM as an example, since that's what we were working with. In the custom templates for regulatory templates, for example, we would provide you with an overview of how the GBM algorithm works, and then we would provide you with references to the actual algorithm.
Wonderful. Does AutoDoc currently support regression type models such as modeling insurance losses that use the Tweedy distribution?
Yeah, so we support, the models that we support include generalized linear models, and that includes the distributions that you noted. So you can do logistic regression, you can specify in that particular model Tweedy distribution. So yeah, there's a lot of flexibility there in support for those kind of algorithms.
Perfect. Can you explain how the AutoDoc performs shift detection?
Yeah, so the cool thing about AutoDoc is we do build some models behind the scenes. For shift detection, what we do is we build a decision tree on each input feature, and the new target is whether a record came from the training data set or the validation data set. And what we're trying to do is identify how well from just a single feature we can verify if a record came from the training data set or the test data set. And then we check the AUC. If we see that the AUC is over 0.8, we'll print out a warning, and if it's a numeric feature, we'll also print out a plot. Otherwise, we won't provide a warning. And I will mention that the AUC, that threshold that we set, is configurable. So you could set it to a lower threshold if you needed to.
Wonderful. Is there a way to specify subsets of the data set and see what model metrics are for each of these populations?
Oh, that's a great question. So right now, you would have to basically build the model on different subsets and just get an AutoDoc per model. But that's a great idea. That's probably something that we could work to add and allow people to use, but we don't have that kind of segmentation currently.
Okay, another question is, should I expect a significant change if I select the maximum, like 10 interpretability option versus medium, like 5 in driverless? Yeah, so again, I think there's just, so what I want to do is separate out. So there's the AutoDoc that is for, that's this current product, and that's for H2O3. So again, for our open source machine learning platform. And then there's driverless, which is our closed source automated machine learning platform. And driverless does have its own auto report, but that is different from the AutoDoc, which only works with H2O3. So I will answer that question because, you'll get different output in the auto report for driverless if you change the interpretability settings. But again, that's a separate product from the one this webinar covered. Great. And we have time for a couple more questions. How customizable is the AutoDoc? Yeah, so that's a great question. So I think the question of customization can be bucketed into two answers. So the first one is like, what can you configure given the out-of-the-box template? So that's going to be through that AutoDoc config class that I showed you in the code. And those are going to be parameters where you can say, enable or disable this feature, or in the feature importance plot, I only want to see the top 10 features, not the top 20. You can also have a little bit of control over the quantile binning. So maybe you want to see 10 quantiles, or maybe you want to see 20 quantiles. That's something that you can kind of fine tune. So you can configure some of the out-of-box plots and tables in the AutoDoc. The second bucket would be customization of templates. So again, if you work in a regulatory industry, you will have your own template. You won't be using the out-of-the-box template. And so in that case, you would work with us. You would send us that template, and then we would work together to identify the sections that you would auto-populate. Then we would update your template with variables that allow us to auto-populate sections, and then that's what you'd run that AutoDoc code on. Okay, and another question is, if we face any issues with the tool, how do we reach the support team? Yeah, so if you are an enterprise customer, your two support conduits will be your customer success manager, and then there's the ability to just email the support team directly. When you do your onboarding, they'll tell you how to sign up with and get that set up. But yeah, if you're using the AutoDoc and you run into any issues, we absolutely want to hear about it. And generally, you'll just be able to email support. It's support@h2o.ai, but your customer success manager can help you with that. And we will then help you debug or add a feature request, whatever it is that you need. Okay, and in the future, will this be available for deep learning like computer vision or NLP? Yeah, so that's a great question. And actually, it's something that we're working to add. So again, not to add confusion, but for driverless for the auto report, there will be sort of image-based analysis, and that is something we're working to add for the auto report. So yeah, long-term in the roadmap, we're planning to try to add sort of an AutoDoc for image-based models, but that's definitely a long-term item. That's a great question. And then the same goes for NLP. What we will show in the AutoDoc, not for the H2O3 models because they're sort of limited on NLP, but for driverless, what we show you is the architecture of the models. Great. And then one last question. Do I need Steam to have access to the AutoDoc? Yeah, so currently, and things can change, but currently the way that you would access the AutoDoc is you would need to be an enterprise customer, which automatically gives you access to Steam, which is the way that you securely launch or connect to an H2O cluster. And then there's just a license configuration that you enable for the AutoDoc, and then you can run the AutoDoc the exact way that I showed you in the Jupyter Notebook. But yes, Steam is currently the way to access AutoDoc. That's great. Thank you, Lauren. And that concludes our Q&A. Thank you again, Lauren, for taking the time today and doing a great presentation. And I'd like to say thank you to everyone who joined us today. The presentation and slides and the recording will be made available on our Bright Talk channel. Have a great rest of the day, everybody.